Yeah, hi, I'm Boris. I'm going to talk to you about the Swift Package Manager today. I'm a core contributor to CocoaPods, and I also work at a company called Contentful in Berlin, where we build a CMS for web and mobile apps. So first the agenda. I'm going to talk first a little bit about what is the Swift Package Manager, then how to make your own package, how does it work, and how does it compare with other similar tools. Right, what is the Swift Package Manager? Essentially, it is a tool to work with these kinds of manifests. So you have a Swift file called package.swift, which might look like this. There's the module package description, which includes the classes used in it. And basically you define a package. It has a name and it has a set of dependencies. And for each dependency, you define where to get it via URL. That can either be a remote URL or a local one for a Git repository, and you specify the allowed versions that you can use as a dependency. And then you basically run Swift build, and it compiles everything that is part of your package and puts it into this build directory, and depending on the configuration, that will be a debug or a release one with all the output. So it compiles and links Swift packages, it resolves, fetches, and builds the dependencies. The current state, I didn't have time. I gave this a few weeks ago. I didn't have time to update it because this first one is not no longer correct. It also builds dynamic libraries now, and it builds binaries. Supported platforms are still OS 10 and Ubuntu Linux, and it only builds Swift code. No C, C++, or Objective-C. There's an open proposal, I think it has been accepted now, for adding support for C style packages, but it's not implemented yet. Yeah, it just has a few command line options. Basically, you can tell it which build configuration to use and to clean. Interesting is the verbosity option, because then you can really see what it does, each command that it runs to build your package. And yeah, it's also open source. It was part of the Swift open source release at the end of last year. So how do you make your own package? As an example, I'm going to use a library for parsing and writing ISO 8601 date strings. And this is how I organize the package. So the Swift Package Manager very much works with convention over configuration. So you would always have the sources directory, and each subdirectory in there corresponds to a module. So if you have a second subdirectory, it will be another module, so another library or a binary, depending on which files are in there. And in this case, we want one module called clock, and it has two Swift files that are part of it. And since it's very much convention-based, we can actually have an empty package.swift to actually build this already. Because the first Swift Package Manager knows it can use the directory name as the module name, and that the source files are in sources. But what to do about tests? This is also not super up to date yet. I will tell a little bit about how it is now at the end of this, but this was basically how it was a few weeks ago. That there was no XC test yet on Linux, so I used a different testing framework for this example called Spectre, and it's a more RSpec-like syntax that you use in there. It looks like this, and it uses exceptions for doing the assertions, so that's why each expectation needs a try statement. And there's a separate tool called Spectre Build, which is used to actually build and run the tests. Since at that point, the Swift package might couldn't do it. So you can just run the Spectre Build tool, and it will build and run the tests. For the purpose of having test frameworks and things like that, things you only use in your tests, there's a separate attribute called test dependencies, which pretty much works like dependencies. but it's just not going to be linked into the actual package. And for this case, we're using Spectre build to do it. I also like to write a make file for the project I use with the package manager. It makes it a little bit more consistent across also different maybe tools. So I usually do this, that I can just run make test, and I don't have to care which method is used to run the tests. And yeah, once we do that, we can run the test for our package, and it runs them all and tells us that they all passed in this case. So since very recently there's testing support in Swift PM using the Swift test command and using the XT test framework, very similar to how you would normally do it on iOS. And yeah, this link is for JP's Smart Talk at TrySwift earlier this week, where he described this a little bit. Alright, another thing you might need to do is changing the Swift version, because you probably have also Xcode installed with maybe an older Swift version that doesn't have the Swift package manager, especially since it's not part of Xcode yet. And to switch between Swift versions, you can use one of two tools. One is chswift, the other one is swift-env. Both work off the same file, which is this .swift version, and there you would specify the exact Swift version you need for this package to work. And it works kind of like all the other version managers for other kinds of languages, so that if you are going to this directory on your terminal, it will change the path so that the Swift version, so when you type Swift, you get the Swift version that is defined in that file. And another thing you might need to do is doing continuous integration. This example uses Travis, and you can use the Travis matrix feature to run tests on multiple platforms at the same time. So you can define this to have tests run on Linux and OS X. And this uses a swift-env install script to set the Swift version up correctly that you need without it needing to be installed on the Travis VMs. And since this does not depend on our package at all, you can basically use the same Travis file for all your packages. One important thing to not forget is that you need to use git tagging all the time, because the package.swift only supports tag dependencies. As we saw earlier, you have to specify the versions, and each version corresponds to a tag in the repo. So if there is no tag, you can actually not use the package. And also don't forget to push your tags to GitHub if you use remote dependencies. Otherwise, they also won't work. Yeah, you might wonder how to maybe interoperate with CocoaPods. You have to do now 2 or maybe even 3 ways for integrating packages. And I started a little tool called Chocolat, and that has basically parses the package.swift and can generate a JSON pod spec. The way it works is actually using the Swift package manager as a dependency, and then you have to do a little setup. So the Swift package manager itself is comprised of several modules, and you can just depend on it in a package.swift. It needs a little bit of setup because it needs to be find the Swift package manager using this environment variable. But then you can actually just parse it using this manifest class, and then you get a representation of the package that you can use from Swift. A little side note about working on Linux. Trying this out a bit, I found a bunch of problems that exist at this point because it's very much in its early stages. One is that Foundation is really incomplete and sometimes different from OS X. And even some things in the standard library are not available. Basically, all features that depend on the Objective-C runtime don't exist on Linux. And sometimes these are actually surprising. For example, there's this function getViaList for dealing with C functions which have VList arguments, and it was surprising to me at least that it needed the Objective-C runtime. The reason is that it needs the auto-release functionality, so everything that needs auto-release actually doesn't work on Linux yet. But there's a different version of this function called withViaList, where you pass in a closure, and inside that you can actually use the VList, and it's just released at the end, so it doesn't need auto-release. Then there's also the issue that everyone who did C before at some point in cross-platform context is that the libcs can actually also differ. This is an example from for the glob function from libc, where one result or one attribute of the result of it is actually just has a completely different name depending on if you're on Linux or on OS X. And there's also sometimes other random funds, so this was actually when I first tried out the clock package, I had this issue. I think it's fixed now, but back then actually it was unclear what is even going on. Alright, you can also integrate existing C system libraries using this approach. You basically create an empty package.swift, and then you create a module map. For this example, I'm using libcurl, and basically you specify the headers that I use. There can be multiple of them, and you specify the library that you want to link against. And this is already the complete package. You can then just use it as a regular package as a dependency. So now let's look a little bit closer at how does the Swift Package Manager work internally. So as I said, it's comprised of a bunch of modules. The first one's actually really interesting for working with cross-platform, of seeing how you can work without Foundation, because the Swift Package Manager actually doesn't use Foundation at all. And it has these three OS abstraction modules for libc, POSIX, and sys. And they contain things like working with path in a cross-platform manner, or executing commands and stuff like this. There's the package description package, which I mentioned earlier. This is the one that you import in your package.swift to actually have the ability to create a manifest for the Swift Package Manager. There's this deb package, which deals with parsing those and making it available to the rest of the package manager. There's the Swift get module, which deals with downloading code, so it deals with git tags and all that stuff. And there's a Swift build module, which deals with actually building the code. As I said earlier, the dependencies can be local or remote Git repositories. They need to be tagged, and they will be stored in this packages directory. So you always have in your package, you will get this packages directory with all the dependencies that you have in the building. The rough build process, the package description module generates temporary structure in TOML, which is actually the last part stands for markup language, something markup language. It's just yet another markup language for stuff. And then the deb package parses this TOML and generates YAML, which is another markup language. And those files are stored in the build directory, and they're used by a tool called llbuild, which is a low-level build system, and that is what actually is executing the build commands. So that is not inside the Swift Package Manager, but it's a separate kind of tool, which is also part of the Swift open source release. Dependencies are fetched by the Swift get module, as I said, and then the Swift build module calls out to llbuild. So a few words about llbuild. As I said, you basically have these llbuild YAML files all over the build directory, and we're going to see how they look like over the next few slides. So basically it tells you who has generated this YAML. Then you have the targets. There's always an empty implicit target, kind of, which has all the targets that need to be built. And then there's the explicit targets. And then you actually have all the parameters for the commands that are being run. At the moment there's basically two things. There's Swift compilation commands and there are shell commands. And the Swift compilation command actually gets all the options are in this YAML file. So you get all the files that need to be compiled, you got the module name, you got the source files, and all the path and arguments that are used. And yeah, these are the build steps for a library, so there needs to be a second pass. The first path generates the object files, and then they need to be put into this static archive, and that is done via a shell command in build, which looks like this. And yeah, you see the actual command just here. And each step in the build YAML file also gets this description, and that is actually what you see in the terminal when you run it in not verbose mode. So this is actually also not hard-coded anywhere. Well, it is hard-coded in the Swift package manager, of course, because it generates this YAML file, but basically it's not inside build, but you can also influence this output, basically. So let's look at some additional package.swift syntax. Earlier I said we have these implicit targets for all things in sources. We get modules, the sources directory, but you can also make targets explicitly, because you can have the issue that packages are interdependent. Right? In this case, we have a package top that depends on another target top, which depends on another target bottom. And normally, if you just would build it, bottom would actually get built first, because it builds in like lexicographical order. Using the target syntax, you can actually express that dependency. You can say, okay, top actually needs bottom to be built first. And this way you can have multiple modules in your package that are interdependent and they get built in the right order. You can also exclude files, because in addition to the sources directory, the package manager also searches other directories for Swift files. And if these are actually Swift files for examples or documentation or whatever purposes, you don't want them in your actual build of the package that other people use as dependencies, or that you yourself build, you can use this exclude syntax, and then in these directories, Swift, the Swift package manager will not care about any Swift files, not do anything with them. I mentioned them briefly earlier. They're test dependencies that work the same as the normal dependencies, just that they are for the test process. Finally, a thing that is nice about the package.swift thing is that it's actually Swift code, so we can also use the built conditionals, like which OS am I on. So if you, for example, need an additional library on Linux because you cannot rely from some functionality from Foundation or something like this, because it doesn't exist yet, you can use the conditionals actually inside the package.swift and change the package description depending on which platform you're on. Basically, in this case, then there's additional source files for Linux, and they will be just appended as an additional target to the package. Okay, finally, let's look at a little bit comparison with related tools. So compared to CocoaPods, CocoaPods has this central repository for discovering packages, right? There's now a site made by IBM which has an index of packages that is automatically generated from GitHub, but it doesn't work the same way as CocoaPods. You cannot search, for example. So discovery is at the moment a little bit tricky with the Swift package manager. CocoaPods has Xcode integration, but that's actually something that also is currently in the works. There's a branch for it on the Swift Package Manager for generating Xcode projects from the package.swift file, so that you have a little bit better integration. CocoaPods also supports other languages, but this is also something that's worked on in the Swift Package Manager. Another thing CocoaPods has is additional metadata in the manifest, right? We have a description, we have information about the license, about the author, things like that, which makes it easier to create this centralized index. And this is also stuff that Apple plans to add to the package manager. Definitely the licenses are a thing on the roadmap, and probably more. And the thing CocoaPods doesn't do, which the Swift Package Manager does, is covering the build process, right? You call Swift build and it builds everything for you, whereas with CocoaPods you still rely on Xcode for the building. Compared to Carthage, the main difference is that Carthage doesn't use a manifest that really describes the package. There's a file for describing the dependencies, but the package itself is not described in any way outside of the Xcode project. What Carthage has, of course, the Xcode integration and support for other languages similar to CocoaPods, things that are being worked on in the Swift Package Manager right now. Yeah, to support all three, at the moment you basically have to do the work for all three things. You have to create the package.swift, you have to create the pod spec, and you need an Xcode project. Hopefully that will get easier over time. Like I said earlier, I'm trying to write a tool to make the going from the package.swift to the pod spec easier. There's also a tool I started that goes the other way around. And generation of Xcode projects is being added to the Swift Package Manager right now. So hopefully in a few months we will be able to not need to generate or like manually create support for all three ways of integrating packages, but have some automation around it. But yeah, at the moment it's a bit sad. Finally, a word from one of the authors is that it's the early days for the Swift Package Manager, so you should think about it as an alpha code base that hasn't had a release yet. I mean, Swift 2.2 was released without it, so it was only part of the development snapshots, and will only be the first release would basically be part of Swift 3.0. So it's useful for doing things, especially on Linux. You don't really have another choice, but you shouldn't think it's a really mature tool yet. Alright, these are some references that I used for this, and with that, thank you. Yeah, this is how you can contact me.
Let's say 3 questions. One of which is not a question. The first one is a statement. For those of you who are standing in the back, we do in fact have some space up here. Of course, you do have to walk through this crowded room to get there. Hopefully there's a path, and you have to take your shoes off to be up there. Second one was, I think TOML stands for Tom's Obvious Minimal Language, because it was made by Tom Preston Horner, one of the co-founders of GitHub. And then my third question is an actual question. So, what is the, the attitude of the CocoaPods development team about Swift Package Manager? Do you see it as something that may eventually supplant CocoaPods? Do you see CocoaPods as occupying a different type of role that will still be useful for certain cases or something? What is your general, stance about it?
It's a little bit of both, I would say. As I said, it's really sad, but at this point, you basically have to create 3 kinds of packages, a lot of manual work to make your library available for all 3 existing dependency managers. So hopefully there will be a conversion that we only have 1. On the other hand, CocoaPods has a few things that go beyond the package manager. Right? We have for example, we have the CocoaDocs project that is, I guess, beyond the scope of the Swift Package Manager. Or we have the central repository, which they might do it in the future, but also seems like this is something that that will still exist. And then there's of course the whole set of legacy CocoaPods which exist, like multiple thousands, I think over 10,000, that will probably either not be converted or maybe not even be convertible to the Swift package manager. So I see it as a way, and basically everyone on the team, that there's still at least some time that CocoaPods needs to exist, and then we're going to try to work as close as possible with Apple to make it easy to use both for the time that they need to exist. But I think eventually it would be nice that we just have a Swift package manager for the dependency management part.
You also doing the CocoaPod, right?
Yeah.
And Swift package manager automatically creates modules inside. If you have two separate subdirectories, and you do the Swift build and you the two.
Yeah, you get multiple modules. Yeah.
I think that auto moduling stuff is a bit hard to use for integrate with CocoaPod because CocoaPod has subspace, right? And you want to create sources directory, and you have a core core sources, and also you add reactive extension directory, and if you specify the CocoaPod subspec, and you specify the directory, those sources, core sources, reactive extension, and CocoaPod worked fine in that way all days. But Swift Packet Manager automatically generates the correct module, right?
Yeah.
So there's kind of difficulty I found. I think it's Swift Packet Manager's fault maybe. But what do you think about it? And how you are able also to develop chocolate?
Yeah.
And
I don't deal with this problem in there. So Chocolate is at the moment relatively simple. It only does a few things.
It's most subspace.
It doesn't do subspecs, no. Because the problem is that basically the subspecs are not modules, right? So they get put into the same module. So there's a big mismatch between the two, as you said. So
subspecs file every file.
Yeah. Yeah, I'm not sure yet.
How is there any way?
Basically, this is I think for the there's no way currently, I think, to deal with this in a good way. And it's a question how to even do this kind of feature, right? The Swift package manager at the moment, you build and builds everything, right? Even if you can get it to not create modules for these other files, you would still end up then with just one way to use that package, right? Whereas with subspecs you can select, and that's not something that exists for the Swift package manager yet. So I don't have a solution for that problem at this point. I'm not sure if that's actually something that the Swift package manager will support, like kind of variants you could say, right? That you can select. I have no idea. The only thing I know that they want to support in terms of like selecting parts of the package is like selecting individual targets. But each target will still be its own module, so it wouldn't kind of solve this problem maybe. You can't really at the moment. The only configuration that's available is like choosing between release and debug builds. That's like hard coded basically in it, but there's no other way to like choose the options.
Currently, we cannot have the compile time macro or.
No, that's not possible.
Can you just clarify? You said something about tag dependencies. Were you saying that Swift package manager relies on using Git?
Yes.
Okay,
yes.
so we should all. I mean, not that we don't, but code in Git, we should add tags for our versions, and that directly corresponds to.
Yeah. Without tags, it doesn't work, and yeah, it only supports Git. Like even if you do you can have a local file URL in this Swift package, like if you're developing, but it still has the same constraints. So it needs to be a local Git repository, and it needs to be tagged. So even if you do locally, that's actually a kind of a problem at the moment because it's really difficult to actually develop a package, like as a dependency. So if you have two packages that need to work together, and they're different packages, you always have to tag locally every change you make. It doesn't have something like the local dependencies that Copilot has. But yeah, there's also no support at the moment, and I don't think it's really planned for like other things like Subversion or whatever. So it completely depends on Git and the Git tags. Yep.
Does Package Manager let you link in, say, an arbitrary static library, which you might have built through some other means? And also, does it have the concept of install, like the make install sort of thing?
Neither at the moment. So I made a few like tools with it because it can compile binaries. It actually, at the moment, is the nicest way to build like a command line tool in Swift because it does the static linking. But I used then Homebrew for the actual installation part. And linking static libraries, as far as I know, that's not possible yet, and it's also not like currently in the works or anything. Might be far in the future, maybe.
You mentioned that that it does the compiling. Is it then just limited to Swift compiling right now?
Yes. There's a evolution proposal for C targets, which I think has been accepted, but it's not implemented yet.
But not C++?
I think it's like they call it C style, so it will be C++, Objective-C's, and C++, I think. But you would still have the problem that I think they said you cannot really mix. So you would say this is a C target and it's all C. So I'm not sure if C++ makes a lot of sense because you wouldn't be able to use it directly from Swift. I'm not 100% sure about how it will work. The one thing that you can do, which of course wouldn't, well, it can work with, no, it can't because you cannot have a framework. But you can you have the support for existing like system libraries. So that way you can integrate C libraries, right? Because they, yeah, that also works for your question actually. If it's an existing library in like the system path, you can create a module map and use it that way. And
Just doesn't work with dynamic libraries?
no, I think it should work with dynamic and static libraries. Yeah. So you can compile it outside, basically, outside of the Swift package manager, and then use this to integrate existing C libraries.
Can we package some static resources like images or zip file into the package manager?
No, not at the moment, because it doesn't build any kind of frameworks. It only builds like the libraries themselves at the moment. But I'm sure that's coming.
There was a question in the back there.
Yeah.
The way to bring the tool to support a free package manager. I think it had, I was looking to at the beginning support free package manager, but also again framework has a lot of things to do, like adding tags and updating post state to for the new version and in market encourage you to update like the web framework. So do you plan to include a kind of upgrade framework in your tool?
Not at the moment, no.
Any your tool is going to be great. Thanks.
Thank you.
Any other questions? Maybe one more.
When we use Cocoa Pod, then source code is available to client side as for debugging. So in this case also source code will be available.
Yes, it's well, at the moment I'm not sure how the Xcode integration will look like. So, but basically the packages get checked out into this packages directory. So the source code is definitely there locally. I'm not sure how the Xcode integration would look like, if it would be readily available in Xcode. But I'm sure there will be a way to do it because it's there.
So that means that it won't build like a package binary that we distribute to people.
Not at the moment, no.
Oh, or at the moment.
I'm not sure if that's planned either.
So what's your favorite package manager?
Arfitch, of course.
Can I coach you?
Yes. Right.
Cool. All right. Thanks a lot.
Thank you.